I never, ever had a board as complex as that one. Every one of us was not aware about what we are going to do here. And all of us highly underestimated the amount of work that it needed. So it does not compare to anything else. The drivers to get this design done were, well, one hard line we had was the manufacturing deadline, because it was a joint project with an American company, with Corning, and it's a government-sponsored project. So we have these milestones, which they call it, and you cannot move these milestones. So these were very hard timelines. This is one thing, and the other thing is just the performance of the whole system, and it needed to be correct the first time. We simply didn't have a second go. The characteristics, I mean, just a few numbers are: it's a 36-layer stack up, 20 signal, 16 power layers. The number of signals is impressively high. It's it's a little bit over 13,000 signals. The number one tool we used when we still were in the schematic phase was CES, Constraint Editor, to put in all these constraints, because it's not just these 13,000 signals, or let's say these 4,000 TIFF pairs. They form, each star forms bundles which have their own rules, especially timing rules. And so we ended up in about 86 signal classes. And without CES, it probably would be impossible, would have been impossible to enter all these data. We used hyperlinks already in the schematic phase, pre-layout simulations. For instance, there was a 64-bit wide bus that with 40 connections, 40 taps. And it is an any-to-any bus. So there is no one master and 39 receivers, for instance. But any of the sub systems could talk to any one of the other subsystems. So, in other words, without this tool, we would have done this bus completely the wrong way. It simply would not work. And this is one example where it was mandatory to have hyperlinks. Without that, I think we probably would have quit. The router, before we used extreme outer route, just one pass would take maybe three to 4 days. I mean, it's absolutely impossible to run test routes just to see if your placement is optimal. And with extreme AR, one pass would take maybe 7 hours instead of 3-4 days, which brought the breakthrough. So we could run the router overnight, and during the day we could do fixes and glossing the whole design and make it filling in maybe necessary empty routes and all that. The success of that design, well, simply said, it's the board worked as it was supposed to at the first go. Everything works, which is, I mean, yeah, I think that's a success.